Good morning, Chris Wrigley, independent agronomist based in Yorkshire, and we're here at the QC laboratory at Safer Grow's establishment, looking at how raw materials are chosen, put together, and what happens to those raw materials to make the finished product. We're here with Martin Edwards, the chemist, and John Blades, the technical director of Safer Grow, just to have a look at one or two aspects and what this laboratory offers Safer Grow. It's quite an important part of the setup here with regard to checking raw materials, etc., etc. Now, one of the things that interests me, apart from that, I see you've got apparatus here. I think that's chromatography over there. This one here is to do with analysing for particle size.
Yes, correct. Yeah.
Why should we want to do that?
Well, particle size is, the smaller the particle is, basically the easier it is to suspend in the water phase or whatever. So they'll stay up suspended longer and everything.
Okay, and does that particle size have an influence on how quickly it can get into the plant? Because simplistically, I look at a leaf, I need that product to end up on the leaf from a spraying point of view, but actually enter the plant. Does the particle size have an impact on?
Because you are increasing the surface area of the particle. I mean, if you do the maths, if you want to do the maths, if you reduce the particle size by half, the diameter of the particle size by half, you are multiplying the number of particles by 8. So obviously you have more particles with a larger surface area, which means you get a quicker uptake.
Okay, so this graph on the screen now is showing us what?
Oh, that basically is just a histogram of a recent analysis of particle size. Here you've got the distribution of the particle size, and here the calculations done for the average. And so you get up here D50 result, which is the average particle size.
Okay, so for a product like the manganese alloy, you're taking a metal, not in the true sense of the word, it's not sort of something that you could file a tabletop down with, but a metal, and then you're actually grinding that metal down.
Yeah.
Is that right?
That's
and
correct.
So to create a small particle size of average values, if you like, to suspend it, but also gain better entry into the plant.
Correct.
And that's what this piece of that's good. Okay, so
part of our specification, when you make the product, you make it to a specific particle size.
Okay, that's important. That's important. John, part of the what we'll see later, I guess, because you've offered us a trip round to have a look at some of the machinery. Here is a beaker of what looks to me to be, well, it's fairly coarse sugar or glass balls, very tiny glass balls.
Yeah, they are soda glass beads. They are nominally 1.5 millimetre in diameter.
Okay.
And they go into our mills, and we'll see those a bit later.
Yeah.
And what happens is they are turned at a very high speed, tip speed of about 17 metres per second, and you pump the slurry through, and the action of those against each other grind the particle size of the product from around 35 to 40 micron down to somewhere between 1 and 2.5 micron mean.
So that's fairly small, 2 micron. How long do they have to stay in that mill to get them down to that size?
The flow rate, it depends on individual products, because we have different specifications and the hardness of the raw materials. But they may stay in the mill, well, without the calculations, the throughput is somewhere around 800 kilos an hour.
That seems a high output to me.
Quite a high output. They're quite big bead mills. Yeah. They're about as big as you'll get.
Okay, one of the things I've noticed since starting this morning is that how many technical phrases you guys use in your working life. I run slightly more simplistically, only slightly, but simplistically. I want to know what these phrases mean, and I keep picking up the word viscosity, which you look at on another piece of equipment over there, and I'm interested to understand. I think I understand it in terms of when I pour oil out and it's cold, it's slightly thicker, and then when the oil gets warm it goes slightly thinner. What influence does the word viscosity play with regard to product?
Well, viscosity is basically a modifier, how thickness. It's just how thick the product is. It's just a method of measuring how thick the product is. And some products are what they call thixotropic, which means when you stir them they go thinner, like paint. So if you buy a tin of paint, it's all thick and horrible. you give it a stir,
Right, okay.
and you can paint it on the thing. So that's what we try to achieve with these formulations. You want them to get thick and stay thick at rest, but then when the farmer comes to use them, you want to make them, he shakes them and they become thin so he can tip them out of the can.
So that's the benefit. That's the benefit. So viscosity means all comes out the can, 3 rinses, job done.
Yeah.
Goes into the tank.
When it's in the can, so it does that. The particles don't go down or precipitate as fast through gravity as they would do normally.
Okay. And this piece of equipment across here.
This is a piece of equipment here where we measure it.
Okay. How's that measured then?
Well, it's measured in centipoise per second, but simply speaking, you take a little probe here and you put it into a container, say something like this, containing your product, and then you just put the probe on, and then you'll put it in your product, and you will type in the speed for the spindle, and that will be dragged.
Right, so it's friction against the viscosity?
It's drag.
Right, okay, so it's almost like torque in a way as an engine would. Right, okay.
It's a complicated piece of maths, but this is at 0 and that's at the speed you set, and you can determine the viscosity because of that.
Okay, that's good. That's good. Now, there's all sorts of other equipment in the lab, and I'm not going to asking too many questions. The QC, the ongoing QC, with regard to looking at samples on an ongoing basis, Martin, that's important as well, because you know, batch number 1 could start off with the right viscosity, but batch number 2, 3 and 4 need to be kept being monitored on equipment like this.
As you make the products, the change in technical can affect the viscosity and what have you.
Okay.
When the product's milled, it goes into the final vessel, where you then adjust viscosity. You have chemicals you add to adjust the viscosity to, again, a specification which is predetermined.
Right. We're all used to batch numbers. It says so on the box.
Yeah.
When my spray operator undoes the box, there's always a batch number on there. How long do you have to keep a sample here in the lab to keep going back to? And do you keep any paperwork regarding that sample?
Yeah. Ideally, I mean, we keep samples for 3 years, because shelf life of pesticides or whatever we make is usually guaranteed for 2.
Yeah.
But we will keep one for 3 years just in case a farmer finds a can at the back of his shed. They are kept because of complaints, the possibility of complaints. Someone saying that
we don't want too many of those, Martin.
No, we don't. But we have to keep the samples in case someone complains, that we can turn around and say, well, we have the samples still, and ours is good.
So it's a backup system for you in terms of quality
control. And the
control.
paperwork when you're manufacturing something has got to be for 5 years. Is usually for 5 years.
Okay, so product for 3 years, paperwork for 5, and that's all about traceability of the product.
We can then pick out the paperwork and we can turn around and say, okay, did we add anything different? Did we do? Because every time we're on the plant, if you add something, you write how much you added and signed by the guy who did it.
So it's a bit like a recipe to achieve good Yorkshire puddings, and if you achieve it once, twice, 3 times, that's the recipe, that's what you stick to.
Yeah, and it's good practice, because any independent judge or whatever, arbitrator, can come back and look through the paperwork and go, okay, it's all in order. If you've got a piece of paper, back of a cigarette packet with just, I added this, then that's no good for anybody, any legal.
Okay, so again, that takes us into understanding what happens with the raw materials, the testing in this laboratory that is performed here, and then, as far as I'm concerned, something equally as important, and that's how long these samples are kept for, so that there is traceability back. And I'm surprised to hear that the paperwork has to be kept for a 5-year period. So that, from my perspective, builds in an awful lot of safety. So that's good.